my own analysis sort of suggested that he may be right, but unfortunately I didn't trust my own analysis, because everyone was saying that things are going to be even worse. So, and sometimes you know you are right, but everyone is saying that they're saying something else, and it's so hard to overcome what other people are telling you. So I guess the point is that you shouldn't always listen to everyone else, although in many cases people generally are right. So, but we will come back to that question. Let us look at some voting systems. Let us say that you have n identical modules. And let us assume statistically independent failures. Yeah, if I had bought any stock when Obama had said that people should buy, I think I could have more than doubled the money. So that was a good call. Statistically independent failures. And basically, let us assume that system is operational if K of the modules are good. Now we will refer to this as the K out of n system. K out of n system. So we have n modules, and if K of them are good, then the system is good. Now we will see a specific example, but let's first see the general solution. So reliability of a K out of n system is given by probability of all the separate cases for which K or more of the modules are good. So let's say I, and let me have some space here. I of them are good, and the rest of them are bad. Okay? And now in how many ways you can choose I out of n? And that is given by, as you will remember, n choose I. And of course, as you remember, n choose I is equal to given by an expression, which is, okay, what is the expression? I don't have it written here. N choose I, that is equal to n factorial, given by n minus I factorial, I factorial. Is it correct?
Yeah.
N choose I?
Yes.
Okay. So, now if you will make a plot of this, it is going to look like this. So let us say you have here you have the module reliability. And here you have the system reliability. And of course, reliability is a number between 0 and 1. And when reliability of all the modules is, reliability of each module is 1, then the system reliability is obviously 1. And when the reliability of an individual module is, each individual module is 0, overall reliability is 0. But it is interesting about how it is in between. And if you have a single module, your reliability is basically going to go like this, linearly. Because that's all you have, right? So for a single module, this is how reliability will look like. But if you have multiple modules, you will notice that your reliability is higher. For a while. And notice here, at this point, reliability of reliability of a system with multiple modules is worse than reliability of an individual module. Does that make sense? Do you think that this can be explained? So remember that if your probability that each module is good is sort of sufficiently high, better than 0.5, then if you put many of them together, the overall reliability will improve. But when each individual module is less than 50%, if it is more likely to be bad than good, if you put more of them, it gets even worse. Right?
So this is assuming serial?
Pardon?
Is this in serial?
No, this is not serial. This is no longer serial. This is a key out of n system. That means you have n systems, and if k of them are good, the system is good. So if it is a serial system, then there is no redundancy. But here they're supposed to be identical systems. So you have n identical systems, and if k of them are same, that they are, and if k of them are saying something, and if that is correct, that means system is good. So if k of them are good, the system is good. That's the assumption. And we will look at a specific example. We are going to look at triple modular redundancy. We have 3 modules, and if majority of them are good, then the system works correctly. So we will see that as an example. Okay, let's see that, and let us come back to this question.
Can I just repeat the justification why the reliability of individual systems are better than the multiple systems?
Oh, in this particular
Yes.
situation, right?
Yes.
Okay.
Can you just repeat why is that? How can you
Oh, okay.
explain that?
Oh, so basically, so basically what I'm saying, if an individual module is more likely to be bad than good, in this case, if an individual module has a reliability less than 0.5, if an individual module is more likely to be bad than good, and if you put more of them together, and you rely on the majority, then it is overall reliability is going to be even worse. And that reminds me of a story. In India, there was a famous poet. He actually got a Nobel Prize for Literature in 1932. His name is Tagore. If you will go to the bookstore here, in what is that big bookstore in Fort Collins? Barnes and Nobles. And if you go to the place where they sell coffee, so you will find 5 or 6 famous authors there, and Tagore is one of them. So he was a famous poet in Bengal, which is now India and Bangladesh, which is now partly in India and partly in Bangladesh. So he belonged to a very large family. In India, even now they have some very large families, so maybe 50, 60 people of the same family, they all live together. And occasionally you will still find that, but it's not that common. So they used to buy milk from the market, so they would send a servant to the market to buy milk. In India, there's a problem with milk that the people put water in milk. So they suspected this servant is not very reliable because the milk seems to be kind of diluted. So they said, okay, we will send 2 servants. So they said, so that they will check on each other. So they sent 2 servants to the market. And it didn't seem to correct the problem, and problem even got worse. So they said that, okay, so these 2 servants, they are not very reliable. Let us appoint a supervisor to these 2 servants. So they appointed a supervisor to these 2 servants and sent all 3 to the market to buy milk, because they used to buy milk in large quantities for their big family. So when the 3 of them went together and bought milk, that they found that there was a fish in the milk. So which basically shows that if an individual person is less than 50% reliable, you put more of them together and it will become even worse. So basically, coming back to the question of majority being right, so majority is right if
If you are in the majority.
each person has more than half.
Yes.
It's a good probability that he's right. Otherwise, if you let's say if you are trying to create a system in some country where everyone is corrupt, then you put more people together, form committees or whatever, things are going to be even worse. So, okay. So let us see an example of this. Let us look at triple modular redundancy, which is an example of this. And this is basically a 2 out of 3 system. And it is actually, the basic principle is quite simple. So basically, you have 3 units, and they are running the same process, and they're identical, functionally identical. They're running the same process. In other words, they are getting the same inputs. So each of them are doing exactly the same thing. And here is the output. Now, what we can do is take a majority vote on the output. This is the voter. And accept whatever the majority of them are saying. So this is the majority voter. Incidentally, triple modular redundancy is also called TMR. Triple modular redundancy is used in some highly reliable systems. For example, in some cases like autopilots of planes, they would consider that. And in some highly reliable, they want very high degree of reliability. Because with triple modular redundancy, if there is a brief failure, then it will be simply masked. And there would be no interruption in service. And so you have a majority voter, and you have some implementation considerations. There are different ways this has been implemented. So for example, this could be a processor, another processor. One situation could be that they are all in tight synchronization with each other. So in terms of, so they're synchronized down to the level of the same clock period. On the other hand, sometimes they could be slightly off, and as long as the voter can take the vote, it is possible that they are not running exactly in tight synchronization. So there could be some implementation differences,